Hello, everybody. Good morning to you all. I welcome you to this premier program of Manav Energy's 10th anniversary celebrations and the experts' discourse on the hidden truth. I am Manoj and I will be your host for today. Well, I'd like to state that some of you here might be unaware that Manav Energy has already been providing electrical safety and reliability to you, your loved ones, and our society. Well, you will know more as we progress through the event. But before that, I would like to take you all through a video that will help you understand how we at Manav Energy have been changing your lives. But before we start off with the video, I would like to request all of the presenters to keep their mics on mute. Thank you.
Safe and reliable electrical systems are imperative for the safety of life, livestock, and assets. This can be achieved with relevant design, correct installation, and appropriate maintenance practices. Working in this direction, Manav Energy started its journey in 2005. We have completed many mission-critical assignments across the world, backed by leading global alliances, industry certifications, and remarkable credentials. Our expertise serves designed for telecom, transport, infra and smart cities, refinery and petrochemical, utilities, process plants, and defense sectors. We provide end-to-end solutions in the field of earthing and bonding, lightning management, EM management, power quality, power systems, control systems, and instrumentation reliability. Earthing and bonding solutions ensure proper functioning of protective systems, glitch-free controls, and suppression of spurious signals. These solutions are compliant with various national and international standards. Lightning protection and management solutions proactively determine time and location of lightning strikes, developing effective energy dissipation and mitigation systems as per sets. It ensures total protection from direct lightning strikes and surges. EM management solutions help to determine unintentional generation, propagation, and reception of electromagnetic energy. It ascertains equipment susceptibility through hazard analysis to achieve higher compatibility of operational equipment from electromagnetic interference. Power solutions are provided to increase usage efficiency and life of equipment. It also helps to reduce noise, heating, and vibration. These solutions include assessment of harmonics, unbalance, neutral currents, power factor, and many other parameters that affect safe and reliable operation of equipment. Power system study assists in the of electrical network during normal and faulty conditions. It establishes stability, reliability, continuity, and safety. These extensive system studies include steady state and transient analysis through software simulations. To optimize process, reliability, and efficiency in electrical network, we offer special solutions in the field of control and instrumentation systems. Accurate assessment of electrical systems identifies loopholes and process shortcomings. It provides to prevent incidents that lead to loss of productivity. This in turn enhances brand image and shareholder value by providing uninterrupted electrically safe environment. Manav Energy, steadfast on the path of engineering ethics, understands the obligation to society, customers, and profession by providing accurate engineering solutions for all types of sectors and industries.
Director and the Chief Human Resources Officer with Manav Energy. From a people function point of view, employee safety is a top priority. And with Manav Energy, it goes without saying, because we provide electrical safety and reliability solutions to the society at large. It'll be interesting to know where and how it all started. So I'd like to invite our Managing Director, Mrs. Savita Banerjee, to share with us the details of the journey. Over to you, Savita.
Thank you, Vijay. Thank you. Warm greetings to my dearest Manav team and distinguished guests. I welcome you all on our 10th anniversary celebrations, and I hope you will enjoy being a part of today's event. I am Savita Banerjee, Managing Director, Manav Group and APAC Business Unit Head. Today, Manav Energy is 10 years old. The fact is, I'm slightly older than Manav, but I'm always young in my role. Anniversaries are opportunities to recollect our memories and cherish them again and again. I still remember the day when we started this company with few handful of people with limited resources and in a garage. Starting from there till today, the company has covered a long and evolutionary journey. Since our inception, we have expanded our knowledge, our expertise, our achievements, and the fields we influence. The year 2012, when Manav Energy was formed, was notable for many reasons. This was when India faced two severe power blackouts, affecting about 400 million people on the 30th of July 2012, and about 620 million people on the 31st of July 2012. About 9% of the world's population was affected that day. In April 2012, US Electric Power Research Institute, EPRI, published a technical causal factor analysis for an accident that was caused due to major earthquake and 15-meter tsunami, which ended actually in a nuclear accident. Well, I'll talk about this a little later, but now on a lighter note, that year was, of course, the end of Mayan calendar, and Queen Elizabeth II celebrated her Diamond Jubilee, and our planet Earth observed the transit of Venus, a very, very rare astronomical event. Coming back, the incidents I mentioned before about the historical power blackouts, I'm sure all of you or some of you must have faced it. Failure of nuclear reactor, which people thought it is because of maybe tsunami and earthquake, but the causal factor analysis showed that the power supply, which was cut off to the melting to the reactors, melted the reactors themselves. Looking at these accidents and incidents, the founder members thought and formed an organization that is purely focused on electrical safety and reliability solutions and services for all lives, livestock, and assets. It's a matter of great pride to see our company growing and embracing a good value system and achieving success more than we thought. This is obviously an amazing sign for an organization. As they say, slow and steady wins the race. We might not have been on the list of the most rapidly growing companies, but we surely have been one of the most steadily growing companies providing unique solutions through disruptive technologies. During pandemic, our business environment saw many changes to which we had to adapt appropriately. I had a small fear in my heart if my team could embrace those changes positively. I'm very happy to share that our team became stronger and more efficient than ever before. My team worked against all the odds, and what seemed impossible, they made it possible. Today, on this occasion, I would like to assert that even under an asymmetric competitive environment, we have provided reliable solutions immaterial of profit or loss. Our business aim is to associate as a long-term solution provider rather than just becoming a vendor. With our present depleting environmental conditions due to global warming, unrest in global political situations, and the unprecedented challenge to public health, the sustenance of industrial operations play a vital role in the near future. Our research and development team are now on the verge of unveiling many futuristic patented solutions that will change how the world will experience this unseen world of electrical safety and reliability. I call upon my team to walk tall and strong and be proud of being associated with this unique company in the world. As one of the corporate values goes, know why is the right attitude for us to be unique and successful in whatever we do. I'm proud of my team, and I'm sure all of us together will form a new era in this electrical safety and reliability. Thank you.
Thank you, Savita, for sharing that nostalgic journey with us. So where do we move from here? That's what the hidden truth is going to tell us. The hidden truth is the experts' discourse that we're all waiting for. And we have a line of dignitaries who have accepted our invitation and are going to join us as a panel. And I would like to invite them all one by one. Before we do that, I want to ensure that you please stay connected for a special announcement towards the end of the program. So let's invite the dignitaries. Dr. Subhash Chand, Executive Director, IRCON. Mr. A.K. Rajput, Chief Engineer R&D, Central Electricity Authority of India. Mr. Dayan Kurkik, Associate Director, Chapman BDSP. Mr. Sanjeev Bhatia, Engineering Manager, Bechtel. Brigadier Bishwajit Ghosh, retired, recipient of Seva Medal and Vishish Seva Medal from the Honorable President of India. Ms. Dinaz Sholapowala, CEO of Xionics Systech Defense and Aerospace Officer with Manav Energy. Sanjay, I request you to be the moderator for this experts discourse.
Hello, good morning, and a warm welcome to all our panelists and to everyone in the august audience who have taken time out to join us today. I'm Sanjay Udgirkar. Before we go further into the discourse, let me ask someone to join who is a patent holder and a recipient of US congressional recognition from Congressman Brad Sherman. Please welcome Mr. Sanjeev Banerjee, Chairman of Manav Energy.
Thank you, Sanjay.
Good morning, Sanjeev.
Thank you to everyone.
Well, today's topic, as Vijay announced, the hidden truth, is in sync with the mission statement of Manav Energy, which talks about safe and reliable tomorrow. As a topic, as a subject, as a phenomenon, it doesn't get discussed a lot or acted upon a lot in the realms of civilian industrial infrastructure. However, in the recent times, it has picked up a lot of momentum, so much so that in 2019, a US presidential order was released which detailed the hazards around this phenomenon and a resilient plan, a comprehensive resilient plan to have a mitigation against the hazards. The topic that I'm referring to is transient electromagnetic disturbances, EMP or electromagnetic pulse as we call it, and this is in the context of electrical and electromagnetic safety. And when I talk of electromagnetic safety, this is for the civilian infrastructure that we have. And when I talk of civilian infrastructure, I mean our ports, our crude storage facilities, our power plants, our solar parks, our data centers, our banks, even our nuclear facilities. So in the course of this discussion, we will focus on the genesis of EMP. We will also focus on the hazards, the range of hazards that it can bring about, and we will also see how prepared we are as an industrial community to manage the hazards. At this point in time, I would request all the panelists that they can switch on their cameras as and when they speak. So without further ado, let us delve into the discussion. Let me first go to Ms. Dinaz and open up this topic. Good morning, Ms. Dinaz. Can you tell us a little more about what is the genesis of EMP? What are the sources it comes from? Depending on the sources, how does it manifest itself? Ms. Dinaz, can you put on your mic, please? Switch on your mic, please.
Am I audible?
Yes, yes.
All right. So basically an EMP is a electromagnetic pulse. Now where it comes from also defines the sort of impact it's going to have on what sort of, items that are in front of it, what industries it's going to impact. So broadly, we normally classify them as naturally occurring, man-made and weapon EMPs. So you will have in the naturally occurring EMPs, you will have the lightning EMPs, you will have things like the solar flares, geothermal discharges that happen throughout the world. Those affect us in a lot of various ways, which the common man doesn't realize. But when they do come into effect, they create mass havoc. And we always were, incapable of rushing through and sort of sorting out our issues at that particular moment. Then there are, of course, some man-made EMP events, like there can be switching surges, there are power line surges, there is places where motors are run. There is always the commutation and things that happen which cause these digital switching has EMP. Of course, the nuclear EMP is what a lot of people discuss or think about when we think of EMP. And there is also now non-nuclear EMP weaponization that is happening all throughout the world. So we have to take care of our equipment, our infrastructure in a lot of different ways to prevent all of this from affecting us.
Thanks, Mr. Nas. Would you talked about the non-nuclear and the nuclear aspect of the EMP.
Sure.
Can you tell us a little more about I understand the EMP, when it takes place, it has different types of pulses around it.
Yeah.
Depending on the source, either from high altitude or from a lightning. So
Absolutely.
would like to know a little more.
So when you're looking at lightning EMP, what you're looking at is a pulse of 1.2 microsecond by 50 microsecond typically. So that is in the microsecond regime. It can even extend up to milliseconds at the maximum. When you're talking about HEMP, which means a nuclear weapon is exploded at a high altitude above the level of the Earth's surface, then there are several other impacts that also come. So it's broadly classified into E1, E2 and E3 pulses, where the E1 pulse is a very short nanosecond pulse. So the rise time is typically 2.3 nanoseconds and the pulse width is typically 23 nanoseconds. When you're looking at the E2 pulse, it has a slightly lesser impact, where it is 1.2 microseconds to 50 microseconds in the case of lightning. It can vary a little bit. This is a typical classification. And of course, the E3 pulses is what even geothermal effects cause E3 pulses, which are in milliseconds to seconds. They can run for enormous seconds, creating large havoc in things which generate currents. So those are the sort of pulses that EMP would generate. And HEMP, sure.
Yeah, go ahead, please. Go ahead. Sorry.
HEMP also affects a very large area compared to lightning. So HEMP, even though overall, if it hits only a particular spot, it may create a shorter effect. But when it's spread across a very large area, there are thousands of industries that would get affected at the same time. So that is something we have to look out for.
Thanks. So we just heard about the theoretical aspects of EMP. So let me ask the next question to someone who has seen the practical aspects. Mr. Sanjeev Bhatia, I would like to know, you have been into an EP, Bechtel actually has been an EPC for 100 years and more, and you have had an experience across continents. So in terms of designing or executing projects, did you have any experience? Did you have any instances where saw a first-hand instance of EMP causing a disturbance in the project execution or planning?
Yeah, thank you. And first of all, thanks to Manav Energy to provide me opportunity to be a part of panel and understanding what's going on in this particular area.
I cannot hear you. Okay.
Are you able to hear me? I'm audible now?
Yes, please.
So yeah, you have brought out the very good thing, because whenever we keep discussing, we talk about EMP, what are the key reasons of EMP, what are the key reasons of high altitude electromagnetic issues. And obviously means from EPC industry and from my experience, I can say a lot of times we people consider this as a quite uh, theoretical aspect. Theoretical aspect in the sense very good to study, very good to understand. When we go into the practical execution and implementation, and then during that time when we see some challenges, that's the key. So I can share couple of case studies. I'll not say case studies. These are the real project execution experience which we have faced. So I'll just take out one example that uh, this was the combined cycle power project which was being executed in California, and the construction was just mobilized at site, and means during the day when the first pile was being rigged, the pile operator got a shock. And until that time, even you won't believe that there was no temporary power at site per se. Means no one could think that even if we do not have the power infrastructure, we do not have temporary power, what can be the reason, right? So this was literally the big issue, that why this happened. There was sparking, that particular operator got the shock. And then when we started looking into the complete root causal analysis of that event, the ultimate thing which we found is around 800 feet away, there were two radio frequency antennas. Means we need to think, say for an example, if a plant operator or the plant developer who is going to build plant, right? Very difficult to think in that direction, that if there are around 800 feet, 1000 feet away, there are AM antennas that can cause that type of issues. As an EPC organization, like we have been in EPC, we have executed more than 100 jobs, either if we talk about power jobs or oil and gas. No one could visualize that particular ultimate thing, that what could happen. So the thing is that there were around 4 AM radio towers, which were approximately 800 feet away of the project site. Out of these two, the wave of one tower was directly passing through the project area, and the wave of the other tower was omnidirectional type of. And when the complete analysis was done, the root causal analysis was done, a lot of site measurements things were done, and ultimate conclusion of that RCA was that this is primarily on account of the interferences, radio frequency interferences, which were happening on account of these towers. Then obviously, like we had to get the complete study done, complete measurement done at site, and I can cover during the subsequent discussion that what came out of this particular analysis, what are the mitigations we had to take in the equipment per se, in the control system, in the electrical system, to take care of that particular impact.
And how old was this?
This was around 2012 type of time frame.
10 years
And
back.
I can share one of the other example. Obviously, means I won't take more than a minute. At that time, I was not part of Bechtel. I was working with Siemens. This was again the solid fuel power project in North American region, and the plant was about a month away from the commissioning and synchronization with the utility. So during the pre-commissioning test and some of the pre-commissioning energization, when the back charge was done, after 3-4 days, there were some relay operations happened, right? Relay operations happened without any flag. When I say without any flag, means there was no issue. That was 13.8 kV switchgear relays. And on couple of relays, when means I only went through the RPA, as I told, I was not part of Bechtel. The thing was the relay contacts spuriously changed their status. And there also the ultimate causal was that around 800 meter away, there were some towers, transmission towers, and which were causing the interference signals and causing these type of contact maloperation, which was operating the clipping circuit into that. And means again, if I talk from the EPC point of view, if someone comes to know around a month before of the synchronization, we can understand that how to first get that, what's the key reasons and how to mitigate and how to take care.
No, I think pretty interesting. And what you said, it just explains why we have named the topic the hidden truth. So it's a truth, and yet it is hidden.
And
now let me go to.
Sorry, I'll just cut you short. Hidden truth, very, very important for the complete participants here. The most important thing is, at least in my 27, 28 years of career experience, I found this type of incident as one of the most difficult type of incident to analyze that this is the reason. Because something is outside the plant limit, something is around a kilometer away from the site. So root causal is literally very difficult because people keep looking into that flag didn't operate. People go into the SOEs, look into sequence of event, opens the transformer, tests the transformer, then ultimately after 15 days, they come to know that what's the root cause of the issue.
Thanks. Yeah, thank you. Now I will extend it to someone, who is in charge of operating one of the longest electrical networks, which is Indian Railways. We all probably know that in terms of the kilometer length, it is amongst the top 3 or 4 networks in the world. We have Dr. Subhashan here. So my question to you, Dr. Subhashan, is that what Ms. Dinaz and Mr. Bhatia just talked about, if we consider the backdrop in terms of the railway networks, what do you think, will be the most problematic areas, or where would you want to focus if you were to look at the impact of EMP? Sir, you are muted. You can switch on your camera, please. Sir, can you hear me? I can't hear you.
He's muted.
Sir, can you unmute yourself? Your mic is muted. Okay, probably we are not able to hear you because the mic is not getting unmuted. Mr. Banerjee, I think it will be very apt, if you can throw some light on what I just asked. I know it's railway network, but ultimately it's electrical network, and you have extensive work done about this.
No, the the railway network is a very sensitive network. And when we were designing the dedicated freight corridor of India, as Mr. Bhatia said, we actually mapped the electromagnetics along 343 kilometers of the network. And we mapped it from 150 kilohertz to 1 gigahertz to actually understand if there is a police communication or to understand if there is another network. We understood the electromagnetics which a transmission line causes on the signal network, which is buried under the ground.
Right.
Yeah. Similarly, the very fact that the rail lines are charged and the electromagnetics of the rail line may cause some kind of voltage between the armor and the core of the signal network. And when the rail person, the maintenance person goes to, touch the signaling lamp, and he may get a shock. And when he gets a shock, it can be vital that he dies. So EN 50122 and 50121 actually specify certain voltages which are the limits in rail network. And when such earthing and bonding is done and a necessary Faraday cage is done, we are actually able to control this. So in rail network, where we see voltages from 2.5 volts, 3 volts to to 25 kV, 2 into 25 kV. These are very, very vital. The whole thing becomes extremely challenging when we go into a tunnel.
Right.
And inside a tunnel, when a rail is plying, that time the rail actually brushes through the air. And during that brushing, it creates something, an effect, which can dislodge triggers of certain systems. So it is called Christopheric effect. So the railway network faces Christopheric effects also, which is a part of. It also faces sophometric currents. And these sophometric currents, these Christopheric effects and electromagnetics, all are withstood across the dimension of thousands of kilometers. To be short, would be my answer. I would love if Dr. Subhash can really.
Hello.
Yes, sir. You're heard now.
Yes, sir. We can hear you.
Actually, I was trying, somehow my video is not there. I'm sorry. First of all, I would like to congratulate Manav Energy for creating awareness among all the electrical engineers and in the public for the electromagnetic pulses. This was absolutely a new challenge which is going to come, and Manav Energy efforts I congratulate. And I also congratulate them for their annual day, Foundation Day. And these efforts which Mr. Banerjee is putting, it is tremendous. When I first came across about this topic, immediately he sent me a presidential order of US, and I could go through the entire presidential order, and it was enlightening to see that how much impact it can cause in the public life. And railway network, when we have taken a decision by 2023, we are going to electrify the entire railway network. And I am also part of that mission, railway electrification. So the entire Indian Railways, when it goes on electric traction, and if such electromagnetic pulse comes, then you can imagine the entire around 600 traction substations we are managing in Indian Railways. And apart from that, as far as passenger services are concerned, we take around 24 million passengers every day, and these passengers reserve their tickets through passenger reservation system. And entire this system is based on computers, highly complicated and sophisticated software. And if this kind of pulse comes and it disrupts our system, the entire country will come to a halt. This is what I have understood, and we couldn't get much lead in this, what kind of solutions we will be finding for these problems. But we have to create awareness among all electrical engineers, those who are in charge or at a sufficient high level where they can take decisions, and create awareness among youngsters and other society people that we have to not only create infrastructure to prevent these kind of mishaps, we have to create awareness, and we have to allocate resources to counter this kind of catastrophe if it happens. I am also told that it happens once in 123 years as a geographical problem, but it can happen anytime as man-made. The first speaker spoke that it can be man-made, it can be some nuclear mishap or something like that. And if we do not have this kind of protection, then probably the entire thing will fail. And we are going to commission one of the major tunnel project in India, that is J&K line. And I have taken assistance from Manav Energy for the first system for conducting the interference studies there. We are taking 25 kV AC traction in the first tunnel, which is connecting Jammu Kashmir to Jammu to Kashmir region. That is Pir Panjal tunnel, which is around Asia's longest rail tunnel, passenger carrying rail tunnel, where electrification is at present going on. And yesterday night also we have done some wiring there. So So this kind of electrification we are going to have, and from Delhi we will be shortly connected with Srinagar with electric traction, and that it is almost 50-kilometer tunnels where we have to put the electrification, and we have to protect all kind of ventilation system and very sophisticated SCADA system. So those kind of protections are required, and the efforts of Manav Energy will go in long way in creating the infrastructure in India. I once again thank you for the giving me opportunity to participate in this, and also congratulate Mr. Banerjee for his efforts, and he is doing wonderful work for solar, renewable energy and other things which will come, which is not a topic at present. It is only a protection topic and electromagnetic protection and interferences we are dealing now. So his work is excellent. I congratulate him, and I congratulate his entire team, including Mr. Munish Mishra.
Thank you.
Thank you, sir. Thank you. Thank you, sir. And as a common user of Indian Railway, it is very heartening to know of the developments and the progress that you just talked about in just now. Let me then now go to someone who is special in terms of his designing capabilities, his knowledge of electrical systems, Mr. Dhyan Kurkek. Sir, having designed so many remarkable projects, whether it is Creek Tower, whether it is Abu Dhabi Trade Center, and so many others, obviously, it takes a lot of integration in terms of the networking, the equipment, and everything that the people could use in such facilities. What do you think, the potentially susceptible areas that we could have in such complex and integrated structures?
Thank you, Mr. Sanjay. And first, I would like to congratulate to you, Mr. Banerjee, and his entire team, 10th anniversary of Manav Energy. Yes, before I answer your question, if you don't mind, I would like to add a little bit more to the wonderful introduction Mrs. Dinaz made, to bring some scientific background to particularly to this man-made electromagnetic pulses or HEMP. When we have nuclear burst, it puts out a pulse of gamma rays. And these are like X-rays, but with higher photon energies, about few mega electron volts. And this thin shell of photons propagate outwards from the burst location at the speed of light. Once low enough in altitude, the gamma rays start striking air molecules, oxygen and nitrogen atoms present in the atmosphere, knocking electrons off and creating Compton electrons. Then the Earth magnetic field causes the electrons to turn coherently, and this constitutes an electric current which generates electromagnetic signal, much like currents on transmitting antenna. And these electromagnetic fields propagate downward as an electromagnetic wave. And unlike lightning, the nuclear HEMP arrives at the Earth's surface as a plane wave, rather than as a strike channel. And melting, charring, and splintering effects associated with the direct lightning strikes do not usually occur with HEMP. The HEMP exerts its influence through induced effects. And primary effect of HEMP, therefore, is the production of large voltages or currents in the large structures and conductors such as power lines, buried cables and antennas, as well as in facility earthing systems. The induced current and voltages may then result in secondary effects such as insulation flashover and electronic component damage or malfunction. We know that logic circuits are particularly susceptible to EMP induced transients. Even small transient in these circuits can cause a false count or status indication that will lead to an error in the logic output. And large transient can destroy junction of solid state components used in this circuit. Okay, just a small digression. I thought you want
to very necessary, sir.
But then to come back to your question, yes, you are absolutely right saying that it takes a lot of integration. These projects in high-rise buildings, particularly. On one of the recent projects where we had 400-meter tall residential tower and 280-meter tall office tower, we had 63 specialist consultants. Various disciplines all come together there. As for potentially susceptible areas, the more susceptible areas with regards to EMP-induced transients are instrumentation and control associated with digital protection relays, fire alarm, firefighting and smoke extraction system, and of course data centers. I'll give you an example of what I consider the most important system, although we have many systems in the building classified as life safety. And these are the ones which are backed up by the generator. I already mentioned fire detection and alarm. We have emergency voice communication system, disabled toilet alarm, staircase pressurization, sprinkler plans, emergency lighting, BMS, PMMS, power management and monitoring system, aircraft warning lights. These are just some examples.
Fantastic. I mean, you could not have been more clear in what you just said. Thank you, Mr. Kukik. Extending what you said just now, I will request Brigadier Ghosh. We all know that he has done a lot of work in the area of EMP, particularly for the defense establishments, and of course the recipient of Seva Medal and Vishishta Seva Medal. So Brigadier Ghosh, Ms. Dinaz and Mr. Kurkik both talked about, man-made as well as naturally occurring EMPs. From your perspective, since this must have been discussed in defense establishments, what do you think, could be the situation in case of a man-made instance of EMP? Brigadier Ghosh. Yes.
First of all, good morning to all our panelists and our participants. And I do believe there are participants from different time zones. So salutations as per the time of the day to all of them. At the same breath, I would like to congratulate Manav Energy on their 10th anniversary and do hope that they continue to do the job that they're doing in a excellent manner, even in times ahead. So now coming back to the question of, I would say human-induced pulses, or man-made pulses, while EMP generally has no known short-term or long-term effects on biological systems, as brought out by Mr. Dejan. EMP so generated can cause temporary upset and even catastrophic failure to modern electronics and electrical systems over considerable geographical areas of the earth. Fixed facilities, mobile ground-based systems, equipment, air traffic, satellite communications, sea and land freight could be affected. Therefore, I think we must be prepared to perform their critical missions in these severe electromagnetic environments if required. Then signal strength and wave shape of EMP varies because of its origin, altitude and location. There are three things. origin, altitude, and location. It is thus convenient to separate, I would say, EMP into high altitude EMP, as Mr. Dejan brought out and Ms. Dinaz brought out. I would say source region EMP and system generated EMP. Now, since Mr. Dejan has very elaborately made you understand what is HEMP, and so did Ms. Dinaz, I will touch on SRMP in brief and focus on SGMP, that is system generated EMP. Now, source region EMP is primarily generated due to a nuclear accident or a holocaust or a nuclear strike. Though there is remote possibility, countries and owners of large assets need to prepare to minimize damage as much as possible. However, the extent of damage can be calculated and preventive measures drawn, which can be probably discussed at an appropriate forum or a session at a later point in time. Now, the biggest threat to the civilian society is from system generated EMP or SGMP. Now, what is SGMP? I can describe it as a wave shape and amplitude of the coupled voltage and current signals on the equipment. I think that is close to the point of origin. And I will now bring out another aspect, that is intentional electromagnetic interference at this juncture, and we may call it an IEMI attack. And this could be a type of system generated EMP. Now, there are various ways to produce this sort of a pulse. Now, one of them is, something called HPM, high powered microwaves. This can be generated by a powerful chemical detonation, which gets transformed into intense electromagnetic fields using a flux compression generator and producing a moving short circuit. Now, this electromagnetic pulse can be directed by special focusing antennas from a mechanically simple suitcase sized device. It has been developed to that extent. Now, this might theoretically, I feel, produce a one-time instantaneous HPM shockwave that could disrupt many computers, communication equipment within a mile. I think something you might say similar to the movie Ocean's 11, if I recall correctly.
Yes.
Now, other methods can also be used to create a reusable HPM weapon, such as combining reactive chemicals or using powerful batteries and capacitors to create this EMP. Also, HPM energy at higher power levels, say in megawatts, and powered for longer time interval, reportedly could cause physical harm to persons near the source emitter, or if possible, possibly if it is in the path of this narrowly focused energy beam. And various known devices that I am aware of is the Jolt, Thor, etc.
Very well said.
I mean, these are eye-opening statements, actually. I mean, you obviously are privy to a lot of stuff which we civilians, we don't get exposed to, but all the same, it's eye-opening. Absolutely. Thank you for that. Let me now request someone, who represents the very backbone of our electrical policy making, structural definition related policies and all, which is Central Electricity Authority. So let me request Mr. Rajput, a lot of discussion has happened in the discourse today. From a CES perspective, and what is happening in the technologically advanced countries in the world regarding EMP, what is CES approach in terms of making certain changes to the policy, or publishing some research papers, or anything else that she is probably looking forward to in the context of EMP. Mr. Rajput.
Thank you, sir. Thank you, all the organizer team. I feel proud that I am here. And first of all, namaskar to dignitaries and all the participants and the team members behind this organization function. Actually, I was introduced recently to this type of the things. Solar flare I have heard earlier, and the nuclear holocaust or the nuclear detonation, those are also the disturbing facts. So these were heard, but irony is this, that in spite of knowing something, this particular topic is not taught in a great detail in the engineering educations. Maybe at the PhD level, some researcher must be doing it especially as a special topic, but not at least at the level of UG or PG. We are taught the conventional electrical power system, and we are limited only to the devices, the protection system, the conventional protection system. It may be the air insulated substations, or it may be the GIS, gas insulated switchgears. So there such studies are conducted. So what is eye-opening is that the lightning is a strange phenomena. Still there are so many theories behind lightning. It causes the direct effect as well as the indirect effect. Direct effect is seen to us, but where and when it will cause the indirect effect is not known to us. Also, in the present circumstances, what I feel, pardon me for my lack of knowledge, it's not measurable also. In the present circumstances, what the measurement system we have. So first thing, as you told that define, let us define first what the phenomena or what the problem is. Let us identify, let us devise and introduce the tools for simulation. Let us devise this measurement system, that how much is the impulse coming and what is the quantum of that. Accordingly, we can devise the protective devices. Similarly, whatsoever the protective devices will be built up, they need to be tested, so that whosoever the user, whosoever is the investor, he becomes confident that whatever he is using is perfectly working and will save his investment, will save his life, will save his assets. So there should be the studies for electromagnetic compatibility in detail. Of course, at typical critical locations, these EMC studies must be getting conducted. As Dr. Suhas told, that it is being conducted for the railways, but I feel that is, I think, for the first time, may not be getting conducted earlier. So that's a new beginning. Right. So whatsoever new such beginnings are coming, the specialized institutions like Manav Energy, they should make a pool of the resources of this knowledge. What we will welcome from the CEA side, we will be getting benefited out of your participation, out of your cooperation in our journey. Because in the electric sector also, what is important nowadays and always has been, that it should be a continuous and reliable power system. And continuous and reliable power system has the backbone in terms of the protective device, of course the bulky physical assets, as well as the micro or the miniature, the circuit breakers, the relays, the communication devices, RTU and the SCADA. And now is the era of the unmanned substations. So since, and we are talking of the smart grid applications also, and overall from the business perspective, the advanced metering infrastructure or the smart meters. So all this will require so many sophisticated gadgets and so many communication devices that will be the backbone of the smart grids and the modern power system. So we should not lose track, we should be aware, and we should devise a set of the items that what could be the possible probabilities which will be causing us, which will lead us into the problem. So that identification once become known, so we can devise the protective measures. And as all the speakers told, that all these EMI could be due to lightning, geomagnetic or nuclear origins, and one is I feel the electrostatic should also be part of it. Electrostatic disturbance is also cause the havoc. So we do not know when and in how much quantity it will come, whether we will be sleeping or we will be awakening at that time. So we will be caught out of a sudden. So configuration of the system has to be in place, and that configuration be simulated, be studied properly. Similarly, we devise the protection system for the new installations, and we amend or revise the protection systems what are the existing one where the upgradation is required. Naturally, the regulatory framework and the CEA regulations on electrical safety, as well as construction of electrical plant and lines, CEA regulations for communication systems, they would require the reorientation and the introduction of these new things. So far, they are not having up to such depth. Some of the things are covered in a partial manner, but more in-depth studies and more in-depth impact is required. So what I would request the participants here, and particularly Manav Energy also here, that CA regulations on electricity supply, this is now in public domain. It is open for comments. So as a part of the education to the policymakers, let you all people offer your comments out of your wisdom, because that wisdom may not be available the one who are compiling. Let us admit it. So earthing and shieldings may play a role to some extent, but what new has to be done and what new material should be introduced as a part of the earthing as well as the shielding of the equipment, that is also required. Damage to protective device I have covered, say relay get damaged, which are meant for protection. If they get damaged, then you can see the fate of the system. If the guard is injured, naturally he cannot protect. So there are components of the DC things also in this one, because this impulse will be of irregular nature. And naturally when this type of the non-symmetric waves and the pulses are there, the DC components in the electric power supply or in the signals will be there. Fault currents may flow through the ground, because a lot of the electrical system is down below the ground also. And the ground as the mother earth carries all the fault current, and it assumes various ways, and naturally the path of the least resistance is followed. So without a fault in my own equipment, say particularly the power transformer or distribution transformers, the fault currents from somewhere else may flow through our neutral, and that may affect this particular transformer. So that type of the case studies should also be highlighted.
I think what you said, Mr. Rajput, I mean, we have to take a note of particularly the fact that CEA is willing to invite people who are working in this subject and, willing to support CEA, and they should be willing to support CEA in terms of, contributing material which will help them, formulate a regulation or a policy or a structural, structural infrastructure around it, actually.
In fact, sir, if I may say,
just one thing I would like to say, that the impact on the overhead physical assets and the overhead protective devices, say I have also narrated, the other speakers have also narrated, but we should carry out a separate pilot study that what effect these EMIM interference will have on the underground systems also, because not many communication cables, the power cables, and the earthing systems, they are all underground. So that effect should be
also examined.
And once again, I will thank Munish ji, Sanjeev ji, and Sanjay ji. And through their interaction, I came to know something about this particular topic, and hope they will be our resource personnel, the resource team for future journey and future regulations. Thank you.
Thank you so much, sir. Thank you. Yes, you were saying something.
You know, I'm able to see Mr. Anil Yadav here.
Yes.
He is an apostle of knowledge, and he's from Deutsche Bhan, Germany. He looks after the design. So Mr. Anil would like to say something in this, because I'm able to see him. Can I request him to talk something?
Certainly, certainly.
Thank you, Sanjeev. But it's Manav's birthday, so not my birthday. Thank you so much for the sweet introduction. Yes, when there is a technical discussion, I sometimes not able to stop myself. First of all, thank you to all the panelists who have contributed today, and of course, I will be taking a lot of information as well as I have learned a lot from here. I just thought that I'll just touch up a few things. One is that, yes, the whole discussion about AMC, EMI touched upon the effects on equipments. Somewhere I felt that they missed out, or our panelists, sorry to say that, missed out the effects on humans. And I believe that also should be somewhere because we have a lot of intelligent people around here. And as our colleague mentioned that not only does Manav provide safety, but at the same time, there are a lot of people who may not be knowing that. So because safety runs somewhere behind. So EMCMI, yes, there's no doubt about it, is important. People are gaining knowledge and people are now getting into it. Rightly, like Shubhas sir said, that in railways, it was not being done. I too, being from the railway background, I could really appreciate what he said. But at the same time, I would like to say is that since the starting of metros, especially after Delhi Metro, EMC-MI studies have been done very regularly. And apart from, of course, the effect on the equipment, because each and every one of us now use metros, we all know that these things also have effect on human beings. For example, say people with pacemakers. So now if they are there on the platform, if the EMCMI is not done and if it is there beyond a certain level, it can create havoc to their heart. At the same time, yes, now with medical devices coming into like a lot of progress being made, I believe that going forward, we have to be very careful about it. That EMCMI should be done not only at places like traction substations or around the power lines, but also at each and every location. And if I'm not wrong, I think that what I know is that in Singapore, it is already a norm that even before you put the first foundation to your house or a building, they do the EMCMI study. So not only for special buildings, but also now with so much of electrification around, it has become a norm to see that, okay, people are living in a safe environment from EMCMI point of view. So I thought I'll just touch upon those things. And one thing I just wanted to add to Mr. Rajput was, if I'm not wrong, because we do some studies and we don't have Indian guidelines. So a lot of times people ask us that, can you just in the studies add what are the Indian standards? For example, especially like with effect on human beings. So what I know is that I think it is IC and IRP, if I can recollect it properly. So those are the standards which we usually use. And when people here ask us that, can you also tell us what is the Indian standards? So we are literally like, we don't think really there is an Indian standard. So yes, I think that time has come that we also have an Indian standard for that. So I thought I'll just add these few things. Sorry to take up the time, and thank you so much.
No, sir. I mean, the aspect that you brought about, the human safety. I mean, it is. I mean, it cannot be underrated at all. I mean, it is an integral part of the. When we talk of safety, we talk of assets, we talk of livestock, and we talk of human lives. So all three are interlinked. So thank you very much for bringing that point out, sir.
Thank you. If I may add, sir.
Yes.
There is a defined standard for human protection from EMP, and Manav does a lot of job about human, because there can be memory loss. Dian Kurkik, who just spoke, has done a lot of work even on how to lay the grounding systems to have a better sleep.
Oh.
Yeah. So the panelist is right here. So in this panelist, there are people who have worked on EMP's human effects. And as Brigadier said, that large EMP can cause you can see a tangible effect in a short time. But EMP is not that. EMP can age things faster. So those are long time damages, and in Manav there is a huge repository of information on human effect of EMP.
I think that brings me to a point, which we referred earlier, in the discussion. We talked about the US presidential order, and obviously, you have been interacting with the international community quite a lot. So, in brief, can we understand where these technologically advanced countries are in terms of their planning, preparation, versus where we are? I mean, how far they are ahead of us right now?
I would say that there are societies which are a no-why society. Means they are not particular on understanding how to do a particular thing. They are very keen to know why do we do this. So countries with a no-why attitude have a lot of deep research, and these deep research countries like US and Europe are quite well prepared because they have been following Mosumi Dikpati of NASA. She exactly knew the Carrington effect, and during this Carrington effect, how large solar flares are going to hit the power systems, and how the quasi-DC is going to enter the neutral of the transformer, how the transformers are going to get saturated, the flux of the core is going to come to the body of the transformer, and the transformer will heat and blast. So the US study has already done and mapped its high voltage transformers. They have noted that over 10% of their EHV transformers are going to blast in terms of when a Carrington effect happens. And the world's capacity to manufacture those EHV transformers is hardly 3%.
Limited, yeah.
So when such catastrophic event happens, they are prepared. So they have already beefed up their stocks. India, we are still awakening. Actually, in PGCIL, there was Dr. Agrawal, who was working on these EMP aspect. A great scientist, he is no more, my respect to him. But India is also working. It is in pockets. Thank you, sir.
Thanks, Mr. So, as you would have heard so far, we have kind of laid out the background of EMP, and we have been able to define the kind of impact that it can have across assets, across human lives, across all the walks of society, in case it were to happen. So let's move the discussion towards, where we are in terms of managing it. And this is particularly for India, and this is again for the civilian infrastructure and industries. So I will shoot it back to Ms. Dinaz. So from a design perspective, when we design a solution for mitigating an EMP impact, so from a design perspective, is it possible to have a common design across geographical locations, or would you have to be customizing it for a particular instance?
So you would always have to customize, because there are a lot of things you have to take into consideration. It's not a one-stop solution for everything. So you have to look at the size of the place, what the place is housing, if it's a building, who works there, how many people are there, what are the exit solutions. As Sir was mentioning, human life is very important. It is, after all, more important than anything else. So you have to take all that into consideration. And then you can, also consider things as I think rightfully Mr. Rajput mentioned something, underground systems, which we don't consider in normal life. They are so heavily affected by things like geostorms, solar flares, and they pass and they go, and there are so many failures that occur, and engineers are confused over the board. Everyone is confused. Everything was working fine, and it's just stopped working. We don't know why. It's because of EMP. It's because we can't see this effect easily. It's because things are traveling towards us from places far, far away, kilometers away. If I can quote one of the trials that we had seen the study of, the USA had done a trial in 1962 of an HEMP, and they felt the effects right in Hawaii, which was 1,500 kilometers or so away from the blast site. And they felt, even the street lamp in Hawaii was bursting. To that effect, we are having EMP effects, but we don't know. No one there understood why till it was, up in the news and it was correlated together. So these are the effects that you see. We also, face a lot of financial losses also. Industries across the board, if there is any sort of power failure, a trip. I recently came across this data which Sir had shared with me some time back. I was discussing with him that one trip in a power system is crores. It is like you shut down for a minute, you lose crores. So that should not be the case. We have to have systems that are up and running in such a way that we don't need to shut down our entire infrastructure, our entire industry to maintain and manage our losses. We have to be capable of running through those. We have to, make our systems strong enough that we can last those things. And of course, we have to always have stocks. Another thing I wanted to mention is while the high voltage section is affected, it is the low voltage section that is affected the most, because we're going into nanometers, we're going into the smaller and smaller chip sizes across the board, and those tiny instruments control everything else. They control our lives. So if we don't take care of the system from the smallest component you're using right up to the biggest one, we have a lot of loss throughout. So that is what we have to take care of now.
Kind of scary what you said. So I think when you were talking about it, so my mind was going to Mr. Dhyan Kurkik. Such tall structures, such wide structures, he has been associated with the design. So, Mr. Kurkik, we would like to know a little more, what aspects, you thought were the most important in terms of, they just could not be, we just could not have any, we had to do it. We just could not avoid it. So those few critical areas, which we must be taking care of when we are designing such complex structures.
Yes. We can maybe talk about the consequences divided into two categories: the ones which are life-threatening and the ones which are just creating discomfort and inconvenience and compromising the residents' well-being. So life-threatening situation would definitely be a loss of network power supply, also at the same time loss of standby diesel generator supply, which we always must have in this high-rise building, and also case of fire. That a main controller of a diesel generator is a major element necessary for generator operation. And the controller with the multiple long cables which are connected to it, which acts as antennas absorbing electromagnetic energy, is most HEMP susceptible element of the generator. So without network and without generator supply, then we have fire detection and the alarm system which will not work. And the worst case scenario, if the fire breaks out, the sprinkler system will not work. Here I'm talking particularly about UAE, for example, because where firefighting does not go by gravity, it is forbidden. The system relies on pumps, main fire pumps and standby fire pumps, and to maintain the pressure in the system. So a firefighting system is normally pressurized 16, 17 bars. We have small jockey pumps which maintain the pressure in the system. And normally when sprinkler head breaks, the pressure in the system quickly drops beyond the ability of jockey pump to maintain it, and the main fire pump kicks in. This is a normal, how it should be. So not having fire pumps and not having also smoke control fans available, this all renders a life-threatening situation. On the other side, if there is no fire, then we can talk about the situation which causes discomfort and inconvenience. That would be the lack of access to building, lack of safety, lack of security, thermal comfort. The main one, which goes, of course, without saying, is losing ability to use lifts, which, of course, is very important in this high-rise building. And also, generally, the building is positively pressurized, just to prevent infiltration of these dust particles from outside. But still, in the building, we have some negatively pressurized spaces like toilets, like kitchens, pantries, garbage chutes. And if there is no power available for the fans to maintain these negatively pressurized spaces, then there is a risk of bad odor spreading. Similarly, for example, if jockey pumps do not work, they cannot circulate the water, which is mandatory requirement. Within 24 hours, you have to circulate a complete volume of water in the fire tanks. And then that would mean that bacteria and the Legionella can quickly develop. So at least water supply will be maintained for a certain period, like a half a day, because we have these domestic water tanks which are positioned in such a way that they feed the apartments and the floors by gravity. So these are some views.
Quite fascinating, I would say, and the kind of elaborate thought that goes behind such tall, big vertical cities that you have been associated with. It's really fascinating, I would say. And then talking of international structures and designs, I think Mr. Bhatia, you would probably be in pole position to tell us in terms of our projects versus international projects. Are you seeing, some developments where EMP as a phenomenon is taken care of in the initial designs and planning of project in terms of what equipment to use, what specifications to use, etc.? If you could tell us a little bit about that, sir.
You brought out again the very good point, because a very interesting discussion which is going on about the causal factors of EMP, HAMP, but ultimately, like within the industry, when we are going for the implementation of the mitigation for all these, because ultimately we can't avoid these, right? We can't avoid interference phenomena. We can't avoid, if we talk about HAMP phenomena, if we are talking about defense facilities or nuclear power plant, but ultimately we have to look into that, what's the mitigation techniques when we are designing the plant per se. And again, if we are designing the plant, what we need to take care upfront when we are conceptualizing the project and when we are selecting the equipment per se. So there are some of the very important testing type of things had already been conducted in North American region. I'll say the simulated type of testings to take care of the electromagnetic interference phenomena, to look into that when we are selecting the equipment, when we are looking into the physical design of the plants, what are the important things which can be taken care of at the conceptualization stage itself. So I'll just take one example of one of the simulated testing where approximately 100 to 200 feet away from these type of interference sources. A large tower was built, and that was for one of the projects which we did when we were starting the project to look into that. What were the impacts of these type of interferences? So there we had built up the very large tower, and after building up the large tower, what we did to do the simulated testing per se, that we had put all the DCS equipment at the bottom of this tower. We had done the simulations by using, for an example, if we are using the cables in the open tray, or if we are using the cable from the tray which is covered. We laid cables to do the simulation to put it in the normal PVC conduits, like, because the good thing which some of the panelists brought out is the underground, right? And if you look
Yes.
into North American region or European region per se, means in comparison to India, there the underground installations are too much and primarily into the conduits, means not the trenches as we do in our region, practically in the Asian region. So we did some of the testings by using the steel conduits or PVC conduits to see that ultimately impact is there. What would be the impact when we are using steel conduits, when we are using the PVC conduits? Means I'm slightly going into more practical approach. That's what this testing was done. Then obviously we did the testing to use that if we are using the braided shield cable or foil shield cable for the instrumentation, that what would be the impact on interference at the end equipment of the instrumentation per se. And after doing all these analysis, the final recommendation which came out and final conclusion, at least in our organization, which we have institutionalized, if we have these type of interference sources or causal sources in the vicinity, all the times recommendation to use the braided shield cable, because obviously like braided shield cables in comparison to the foil shield cable have the better noise rejection rate, approximately 2 times better in terms of noise rejection. But obviously then again, we need to look into case by case that what type of sources are there, right? Braided shield cables are good for the noise rejection for low frequency and mid frequency, but if we are talking about the high frequency coming out of the source, foil shield will come out the better option. But in general, if we talk about more or less the forces which we have seen, if we just leave lightning type of thing aside, are the artificial forces. Like, say for means when I'm talking about the plants and interferences plus se, right? So one of the major which we normally take it to use braided shield cables. We in general always recommend to use the covered trays, at least for the instrumentation type of cable, because that was ultimately came out as a result when we did that simulation. Use the metallic conduits, at least for the instrumentation cables, not the PVC conduits. And one other important thing which we observed is for the heart communication. So this is still for us as an organization within EPC, I consider this still as an open-ended area, because we couldn't converge in so many years that what ultimately is the final recommendation, because varies a lot from case to case. And one of the other very important aspects, as I think Anil sir just touched base about the human safety. And when I started, I also talked the first incident, at least which I had seen in my career, is when one operator got the shot. So to do this, our normal recommendation is that whenever these type of equipment are being used, good to do the bonding for these type of equipment with the tar, to use some sort of like if we talk about the winch ropes, we have to provide some sort of insulation. We have to do the bonding of these, because again there is the different practice in the region to region. If you look into European practice, whenever these type of heavy lift equipment practice are started, they first they put the pile and they do the pile bonding with the earthing system to have the complete plot as the equipotential bonding, which is not very common if you go into the North American region or Indian region. We do the pile earthing. Sanjeev can correct me, we do it, but not to that extent as the European region primarily focused to do the pile earthing to get all these bondings properly done. So these are the few again, I'll say the very basic steps which we do. Right. And we normally in general always prefer to go to OEMs to look into that if we are providing the ferrite force type of system to take care of these interference phenomena. What is their recommendation? whenever we are using thermocouples for these type of reasons where we see that there is a probability of interferences, using the transmitters to take care of that. For hard communication, even I told that still this is open, but in general, our experience is that ferrite cores are quite effective in terms of the hard communication to take care of these phenomena. If hard signals are non-functional per se, I think everyone understands when I talk non-functional, we always prefer to use the tri-loop or a transmitter to bring the 4 to 20 milliampere signal back to the DCS. So these type of, some of the again, we can say are a very basic measures, but we take it in our design from the conceptualization stage. And I'll just take a minute more from the hemp side, because honestly, I don't have much experience. Even in 2001-2, I had very specific training on the hemp from Munich. And we did it, some of the hemp mitigation measures for one of the nuclear power projects in the Finland. So they are obviously like one of the important measure which in general everyone takes nowadays to provide the building shielding. And this shielding is primarily using the copper embedded in the concrete for the building. And obviously this is the very, very thin mesh type of shielding. But again, these type of facilities, the challenge is that we have a lot of equipment which is outside the building per se, right? If we talk about transformers that Sanjeev touched, this is all outside the building. So there in general, in these type of plants, people rely more upon the reliability, more upon the configuration. There are plants like in general, most of the EPC industries, like if you look into Samaton type of industry, this is pretty standard practice for them to use the hemp filters if something is going outside, to provide the surge absorbers actually within the cable circuit to take care of the hemp phenomena for the commodities which are outside the building.
I think what you said, the comparative measures that India versus Europe versus US, I think again, I mean, from a personal standpoint, a lot of information there for to capture actually.
But one of the very important points which Sanjeev also touched, that in general I have seen in European region and North American region per se, right, which I haven't looked into more in India or Middle East type of regions, that yes, there are very well awareness about the mitigation and protection from lightning type of phenomena. But if you look into the man-made interference phenomena, start thinking after then the project is at the advanced stage of construction per se, not at the stage of conceptualization. And in general, in my view, it's very difficult if we don't think all these design aspects during the conceptualization phase, because this requires a lot of OEM interfaces also.
Correct.
I'm talking from the EPC perspective. I'm talking from the project developer perspective. After 8 months, a year, because we have to talk about who the protection systems to take care of. As someone mentioned, that this is the guard of the plant, right? That what to do to take care of protection system, what type of shielding we have to provide to take care of these impact. Because nowadays, if you look into SEL, Siemens, everyone has these type of measures, that what can be taken care of, the spurious contact operation to take care and to mitigate these type of phenomena.
Understood, sir. I think very well understood. That I will extend a little bit to Brigadier. We talked about the electrostatic as well as electromagnetic effect of EMP. What do you think, sir, in terms of our preparation that we would need, or from a planning standpoint, we would need to, let's say there is an existing establishment, which needs to be protected, which needs to be given a solution for, what parameters, we will consider, what measures we will consider to ensure that there is a protection available. Brigadier, sir.
Mr. Sanjay, I just want to respond to 2 issues that came up during the discussion. First, I think one of the panelists talked about, radiation hazard, I would say. It is not a very common phenomena, but in places where it is required, we carry out radiation hazard assessment okay, of all the electromagnetics that are around you. So in nutshell, there are places, there are I would say organizations who carry out such assessments. And I can tell you, like, say, what are, and in these assessments, what is happening is that frequency wise, what is the I would say the voltages which are required, which volt per meter it is given. Say now I can recollect that, say, a Wi-Fi signal, which is a very common thing in a house, say 2.5 gigahertz signal, I recollect it is 61 volts per meter. If it is going beyond this, that means that equipment is not as per the desired standard. So while you design a bigger facility, so all these small equipment and gadgets which are within our house and to which we are in close proximity to, like our phones and other things, they are radiation hazard inputs for the same. And from here only, it can be known as to whether it is within the susceptible zone or not. Now, when we design a facility, then a separate test has to be carried out. And suppose there is a HT line going. So that means there will be radiation hazards if you are working directly below and workers are coming in close contact to that area. So that is one. And now, secondly, I would also talk about something, about the effect of infrastructure. Now, I remembered while you were showing your initial slide, you talked about a US Commission report, and yes, which has come out, which is the Trump's talk or the Trump's presidential order is the effect of that US Commission report. Now, I just want to tell our viewers that, the summary there was a study, there was a study which was carried out, a virtual hemp attack, and estimates of damage and recovery time in Washington, DC was carried out. And this was presented to the Senate. Now, in this, the cumulative damage that was determined, it was under 3 categories: the low, medium, and a high. And the summary of the same was that on low capacity hemp attack, around 30%, medium capacity around 40%, and high capacity around 70%, unprotected electrical and electronic infrastructure was damaged. And the time required as per the study for getting it back on rails was approximately 1.5 to 5 to 10 months respectively. And another important thing is that what all was there. There were transformers. They carried out study on transformers. They carried out study on large and small communication systems. They carried out study on SCADAs. Then they also carried out study on large and small electronics. I'm talking about 2007. And this was the result. So we need to understand that this is also a very important thing in terms of if at all such an attack takes place. Now, coming back to the protection that you are talking. Now, EMP and intentional electromagnetic interference protection of a building, factory, facility or infrastructure is an arduous process. And it is a very, very vast subject. However, I've been involved in it for over a decade. So I will, what I'll do is I'll broadly touch upon the concepts of these hardening, because in such a short time, it's very difficult to put it in a package. Right. So, and I can also see Mr. Banerjee sitting there. He may also further elaborate on this subject if he wishes. Then, sure. So I would say let's talk about the first aspect is shielding, then hardening allocation concepts, and shield penetration and protection concepts in terms of how to protect it. Now shielding. Now let's take this word shielding. Now for hemp hardened facilities, like some EM shielding is always essential. If you have to harden it, EM shielding is an essential aspect. And this involves the use of barrier or series of barriers to reduce the magnitude of this EM energy which is coming in. Like I remember Mr. Dejan, talked about the plane wave. So we actually need to understand the frequency and this the E field, the H field, and the plane waves. But I don't want to get into it because it becomes too technical then. So as a layman, I would like to explain that all these things have to be taken into account. Now, shielding philosophy can be developed around global, zonal or topological shielding or tailored shielding systems. So now what is global shielding? So global shielding is a protection concept that uses an overall shield to encompass the entire facility. And in this approach,
sir,
what we do.
I will hold your thought there for a minute, sir. Before you go deeper into this, sir, let me get to Dr. Subhashan.
Okay.
From a railway, which is such a important carrier of the country.
Okay.
In terms of our planning, sir, what is the plan that Indian Railway has in terms of any plans we have for upgrading our equipment from a EMP shielding, EMP protection standpoint, sir? If you could just briefly tell us about it.
Can you hear me?
Yes, sir. Yes, sir.
Actually, as far as metros are concerned, on the viaduct, right from the pillars onwards, from the pile onwards, the designs are available, and we are working in NCRTC project where the earthing designs have been done, and right from beginning it is taken care. As far as underground tunnels are concerned, we are doing the EMP studies, and we are also having simulations for these studies. And corrective measures are taken, and we are creating mesh, and then today electromagnetic pulse, for that there is no such protection. I think more protections are required for that. And railways have got a earthing and bonding plan, and in AC traction manual they have covered it well for the earthing and bonding. When we do traction, railway traction, the bonding and earthing arrangement is one of the important arrangement, and even the platforms are earthed properly and independent earths are provided. So that is the protection system which we provide and what is known to us. But today's topic is more of an innovative kind of a thing, which is going much beyond what we know at present.
Yes.
So railway electrification, bonding and earthing is done in a good way, and it is the point in which is checked by electrical inspector at the time of opening the section. Earlier, somebody was telling at platform, if that kind of a interference come, then a patient or human life may get affected. We have come across a situation in Malaysia where one child got electrocuted when we did the electrification. So proper bonding and earthing arrangement, because that child was carrying some toy in his hand, and then he pointed towards the OHE. And some transient happened, and there was electrocution. So we have to completely shield all these things from the safety point of view. So railways have something bonding and earthing plan already available in ACTM. It is clearly defined, but new things have to be taken into consideration as and when the standards are open in from CEA or from other agencies. Thank you.
Understood, sir. Understood. Thank you. Thank you so much, sir. Mr. Banerjee, we heard from all our panelists about how EMP can impact, interrupt, paralyze probably a host of equipment. So, and you of course have been working on interacting with international community a lot around this. So from a preparatory standpoint, where are we? I mean, in Manav Energy, to provide solutions either to the country or anywhere else, what is our readiness? What are we doing? If you would brief us about that.
I think the answer to your question is the program, where the first association is the awareness. We don't know what we don't know, and hence we are calm and satisfied. The day we come to know what we don't know, our awareness campaign will begin. That is why we named this particular program the Hidden Truth. Now, the very fact that people like Brigadier, Dinesh, Rian, Sanjeev Bhatia, all of them are together. And it shows that they already have certain knowledge. This teaching of the knowledge is Manav Energy's primary responsibility.
Right.
And after that, we have formed a lot of consortiums of specialists who have prior experience, have research data, have done experiments, so that comprehensively we will be able to mitigate this challenge. Today, at least, very clearly I can say that given this threat, Manav Energy is able to provide with its consortium partners complete safety from E1, E2 and E3 hazard. We will be discussing maybe in the next panel discussion or this panel discussion if the time is appropriate. Thank you, sir.
I think what you said it triggers a lot of thoughts, that off and on I have witnessed you working upon in the lab, in our research lab, talking to people you just mentioned and all that. So from a solutioning standpoint, do we, I would like you to a little bit elaborate on the solutioning aspect. I mean, let's say if it's a design, if it's a simulation, if it's a validation, or the underground arrangements that were referred to a number of times. So from a grounding and shielding, stitching to the E1, E2, EMP protection, if you can tell us a little more.
I thought I escaped, but you still pursued. So let me say that when we look at any installation or establishment, we see greenfield projects and brownfield projects. So when we are looking at greenfield projects, we're looking at advanced Carson's rules, we are looking at Eugene's formulas, we are looking at various grounding aspects, we are looking at tangling between conductive currents and dielectric currents. So all these things are there. It is a design issue. But when we are looking at established institutes today, India is going to be $1 trillion economy. So there are already refineries and everything. So first thing is validation. And this validation is done in many facets. There is a time domain validation. So there are already small suitcases in which we can inject an E1 pulse into an institute and see its susceptibility. Once we know its susceptibility, we can cure it. Similarly, as Brigadier said, that various frequencies have different consequences. At Manav, we can see from quasi-DC to say 18 gigahertz in civilian establishment and up to 40 gigahertz for defense establishments. So we have all the antennas from loop antennas, pin antennas. We can see the EM even in an IC chip. So we can see all these equipment. And in railways, we see EM for 3 kilometers. So this is a frequency domain analysis. After the frequency domain analysis and we understand the ambient environment, we can put all these different sources inside a simulator Then we can do a simulative validation. In a simulative validation, we can see inter-system and intra-system hazard analysis. But when we do a validation, we come to know the true condition of an institute, and then we get to design. And in a design, what we can do is we can change the frequency from quasi-DC to 18 gigahertz. So we can see the porosity of the walls, the porosity of the Faraday cage. We can do all of this in simulation. It is not a hit and trial where you put mesh or copper plate or the concrete or the thickness. All of that you can put inside the simulator. And inside the simulator, we can create a nanosecond waveform. And we can use our filters. So these things can be done inside the simulation. And then a total scheme can come out. And in that scheme, there are primary Faraday cages, like Brigadier was. Actually, we stopped Brigadier at a very crucial time when he was saying global protection, zonal protection, and tailored protection.
Right.
So this is basically, there is a global Faraday cage. There is a zonal Faraday cage. And then we can give even filters, primary even filters, secondary even filters. We can predict E2. We can enable certain devices. We can predict E3. And we can enable filters for those things. We can switch between solid grounding to a capacitive grounding, because capacitor blocks the DC. So when we are doing all these schemes, we need products. Fortunately, in India, these products are already developed. They are fantastic even filters, and in our consortium, we can provide even filters. We can link the even filter to the command center, because you always have to see whether the filters are working. Similarly, recently, when in an industry, when there was a loss of life due to certain E2 incident, we were given the opportunity to manage E2. So we could predict E2. And from prediction of E2, we could enable certain things which can ground the E2 filters. We have our firm, which is basically an E3 prediction system. And using this E3 prediction, we can operate disconnectors. These E3 prediction systems are disconnectors. Some are patented, some are patent applied. So these entire gamut of system already exist in India and available for the world. But whatever you do, whatever filters you provide, sir, it is not possible to do anything without a proper grounding. So at least we took upon, Manav, you asked a previous question to me that what Manav did. Manav has actually mapped the entire India, the main soil and associated soil. Today, every countryman of India can put his GPS in the website which is launched today, which is called Masiha. And by putting the GPS, he will know his soil resistivity and isochronic data online. So it is not about industry, it is about your home and my home. When I am making an earth pit, I don't know how many rods to put, but when you go to Masiha will tell you how to make your earth pit. So when you go to make an earthing system, see, we have diverse soil. We have rocks, we have ice, we have sand, we have so many systems. How are you going to integrate these things? So we need some kind of compounds which can grow in the pores of granite. Because nothing is permanent in the world. We call about chemical earthing. The chemical earthing is not permanent. Only death today is real. So the death can be catered or countered only through growth. And once you have a growing compound in earthing, then you create numerous hairs around the facility. And these hairs actually increase the surface area of interaction between the soil. So the capacitance of the earthing system grows heavily. And that's how you can have a complete solution. I think this is more than sufficient for today. Later we can discuss.
No, absolutely.
further.
I mean, it's a subject, which is fascinating. At the same time, there is a possibility to go into as much depth as time and opportunity allows. So, but all the same, thank you so much for those enlightening insights. I would say, considering the kind of interruptions, the potential of EMP, to cause disruption that all of us, all the panelists talked about, it's quite reassuring to know that something is being done. There is a capability existing with Manav Energy, as well as there is work being done to take us forward in terms of how we will be able to manage these disruptions in future. And thanks a lot for that, actually.
Thank you, sir.
But all the same, as you talked about, the need to stitch, the corollary to that is the need to understand, the need to recognize, take cognizance of the need to stitch. And there must be leaders in various capacities, in the audience, who would be managing facilities of electricity production, generation, transmission, distribution, refineries, process industries, and all of that. So it is for such leaders, to take cognizance of the discussion that we had today, the potential to experience firsthand, in case of such a disruption were to happen in their facilities. And in anticipation of that, to, I would say, identify the potential points of concern in their respective infrastructures, and to come up with a plan of defense. And then, something can happen in future along the lines. My personal takeaway is, that the better we have a shared understanding of the subject, the better we are able to recognize the disruption, the challenge that it can bring to our infrastructure, civilian infrastructure, particularly in future, the better we will be prepared to handle this.
Sure.
So with that, we come to the end of this discussion. I would like to apologize if I had to interrupt someone, or if someone did not get enough time to present their entire viewpoint. My sincere apologies. And I would like to thank all our eminent panelists, as well as everyone in the audience, for a meaningful, engaging, and thoughtful discussion. Thank you.
What an insight. What an insight. Thank you, Sanjay sir. Thank you. Well, I would like to say that we all here are privileged to have had such esteemed dignitaries as the part of this panel discussion. Well, we all do know that you all are here amidst your busy schedule to be a part of this experts discourse. Hope you are enlightened. Well, without further ado, I'd like to invite the man who has been serving the Indian power industry for over 3 decades as the electrical head of Center of Excellence for NTPC Limited. He is now the Director for Marketing and Technology here at Manav. Here is the one and only Mr. Munish Mishra. Over to you, sir.
Thanks, Manoj. What an engrossing discussion. I hope today's discussion has benefited the industry at large. Back in NTPC, when I was in the operational services, there were so many unexplained trippings and failures. Actually, my association with Manav Energy, and especially Sanjeev, helped me to migrate from a know-how platform to a know-why platform, thereby addressing lot many issues. Are you able to hear me, Manoj? Am I
Yes,
audible?
sir. Yes, sir.
Okay. So we at Manav Energy additionally stress to resolve problems permanently. Like Sanjeev has already mentioned about Curec Plus, the magic earthing compound. This can polymorphically grow in rocks, desert, any soil, any terrain, and performs well without water presence throughout life. We are an innovative and R&D based company. Many know about our firm. Sanjeev also just pointed out about the patented product. So this patented product of ours is able to monitor your earthing systems both in the steady state as well as in the state of fault, and gives you more information on your mobiles and laptops. We also develop products based on customer requirements. Although LMAS was shown as a E2 device, but yes, that was developed as per the requirement of one of our esteemed customers, so as to give an advance warning to their human assets in the vicinity so that they move to safer places. Customer satisfaction is important to us, and reaching customers' delight for any project is what we strive for. We've done some good work over the years and received a lot of accolades and appreciations from customers. One being from NTPC, where we commissioned the excitation system of a 800 megawatt generator, where actually OEM had backed up. Thereby, the machine was brought to bar much earlier. For Savronic, similarly, a Turkish company, we completed a job of earthing design, supply, and supervision. This is the tunnel, which is 9.2 kilometers, the longest tunnel at such a height, with exceptional results and a lot of cost savings. For Shams, a renowned power company of Middle East, we recently addressed a problem when OEMs showed their inability. In Mitsubishi Heavy Industries, we were able to provide relief to their voltage-related issues permanently. Today, in this August gathering, we also have representatives from industry. Adani Power has been utilizing our services for a long time for all their stations. I would now request Vice President Endos P&M, Mr. Uday Trivedi, for his words of encouragement. Mr. Uday Trivedi, can you kindly unmute and Mr. Uday Trivedi?
Yes, I hope I'm audible.
Good to have you, sir.
Same here. Nice to see you too.
Right.
So I hope I'm audible.
Yes, I can hear you, sir.
So thank you, gentlemen and ladies and gentlemen. First, congratulations, Manav, for this Foundation Day. Wonderful initiative, very good, initiative for knowledge sharing as well. We all know that since last few years, especially, there has been huge complexity in terms of volumes as well as all the complexities in power systems. I will be specifically referring to power system, all electrical systems. And we have challenges from everywhere, right from lightning to grounding and everything in between. And today and before some time, I was introduced to these EMPs. We are actually getting more threats. Now, this need detailed investigation. We need measurements. We need simulations. We need testing. We need various methods to actually try to understand what we are dealing with, what we are going to deal with. Apart from audits, very extensive audits and measurements for the existing issues and to check and possibility of problems, we also need to design our systems accordingly. More critical aspect is to actually now we want to deal with future. The important aspect will be to deal with the manufacturers also. When we are referring to products, we are able to deal with all these complexities. Apart from users and practicing engineers, we need to involve the manufacturers also to see that we are able to actually proactively deal with the challenges which we are going to face or which we are facing. Now, we have been, first, I would congratulate and thank Manav and Mr. Sanjeev Banerjee to, so it's a very simple statement that you have helped us to change our orientation from electrical to electromagnetism and even physics. So when there is a lot of, it is quite fashionable to talk about ITs and markets, it is much more important that we talk about physics, and that is exactly what you have been doing, and so effectively. We feel much more awareness gets generated to all the practical engineers, even businesses. One, important aspect is that even businesses right now are not completely aware of the issues. The focus is on somewhere else. We need to be aware. The business need to be aware of how to deal with these problems. Also, they should be aware of the problems, and we have started doing it, and quite rightfully so. And again, Manav gets the credit of focusing attention on the issues which are much more critical in nature. So at Adani, we have been using your services at our many of the plants. We have audited systems. We have actually brought down the failure rates of not only electrical systems. We improved safety. We improved failure of electronic cards. We improved vibration related problems, and we expect it to actually, because as we are expanding, we intend that we should be able to extend your services to other areas also. Data centers, as you rightly mentioned, and wonderful panelists I've been listening to, they have been referring to a lot of issues. We know that our dependence on instrumentation IT is actually increasing. Data centers are also increasing. We are much more dependent on components and all these things, much more, right from generation, of course, transmission networks and a lot of electronics is actually is part of our system in even loads. This poses a lot of complexities, and Manav has started doing a wonderful job. They are able to offer services. They are able to actually offer not only services, they are creating awareness. They are actually offering solutions as well. I wish we are able to take that journey forward, not only from Manav, as Mr. Banerjee has right now already mentioned. He wants to percolate this to everywhere, to every possible, industries and manufacturers. So wonderful initiative, Mr. Manas Mishra, and thanks for inviting me. We wish that we can continue to listen to such wonderful discourse from many of the experts, and nice to invite me again. Thank you so much.
Thank you, sir, for your kind words of appreciation and the challenges which you pointed out. We are taking note of that. Definitely we'll work on the upcoming challenges. Thank you, sir.
Pleasure being there. Thank you very much.
So we also have in the gathering Sri Ranjit Thavar, who's Senior General Manager, Power and Protection Systems at Reliance Industries. We have been catering to Reliance for a pretty long time and would like to hear from Ranjit ji on his thoughts on the discourse today. What are the takeaways and how he and his team would be benefited? Ranjit ji, please.
Yeah, good afternoon all. And I want to congrats for glorious 10 years of MAPL to each and every team member and their extended family members also. It's a great celebration. And I think MBPL journey with RL started through G. I understand that, and for some small amount analysis which was not getting clear, and then MBPL stepped in and done the detailed RCA and give the solution. And after that, I actually forgot that problem. What was it? So that after that, the solution was given. And now MEPL is not only the earthing and lighting system, but he has diversified in power system and protection system studies, EMTP studies. I'm honored that I witnessed such a great session today, EMTP with all these panelists. It's really, and this EMP is also not threatening to the tracking system, but it is for industries also. It is affecting industry also, and we are looking forward more and more information and mitigation plan for this EMP. But the furthermost, as a petrochemical industry or polymer industry or such type of industry, our major requirements from such consultation and agencies or firms like Manav is that I would emphasize on the 5 major systems which already MEPL is embarking on that and shown their demonstration on this particular aspect. First is system. There has to be a system where when you are collecting the data, when you are submitting the report, when you are analyzing the things. So data collection seems to be a very simple thing, but if it has to be correct, it has to be error-free. So for faster error-free works, a system has to be set up which can't fail. So creating a sample template for collecting data, because as a analyzing the system study report, I could find that at very first stage, input data is not correct, and then report goes aware. So that's the point I want to make, that such type of system has to be done. Then quality, second part, that report quality and deliverables. So it is always to have a peer review within the department, within the group, and then that final product has to be presented to the system. And I will appreciate on this aspect MEPL has given this quality, and that is we have done some studies and through MEPL, and I could find that very this way. That, but it has to be documented. Yes, we are doing peer review. Any protection system or any books you refer, it's always a major point. Always so that you should have one third eye look on that your report. And then third, with after this, that you have to provide a service support. And service supports, I will just like when marketing team come to first face value of any agency is a marketing, and they give you the overwhelming promises that we will do this, we will do this. But then when actual technical team comes into the field, who's actually after getting the job, then it some dealing observed between what has been promised and what has been being delivered. But yes, in MEPL, I could find that it was a marketing team which are doing the promises. It is being backed up by the supported by the backend technical team, and they work in a tandem. That has to be shown, because without that, your value, your words value cannot be there. So that's a really good thing. And especially I should mention for this that one scene that we have taken earthing, permanent earthing system solution from the MEPL, and initially we faced challenges that one part is material management and other is services management. Material management, we could have an annual rate contract and we have managed that, but services, it was very difficult to get services from MEPL each and every time. So our local contractor has to do that job. So then there are number of sites in geographical area, how to ensure that quality is given by that product. So we jointly create one field design specification document, and which is strongly supported by MEPL. Now I am not aware how many people are using that document doing the earthing system within RIL. I think more than 5,000 in manufacturing site. This earthing pit has been completed, and geo it may be more than 2.5 lakh. And geo engineering project, yeah, geoengineering project team were asking me, is such we have any document that time? And that time I was just preparing that document. And once it was prepared, and they never come to me then again how to do this job, because that document itself is a guideline or technical support for them. So this is the thing. And the third point is also collaborative work. Now, what do you mean by collaborative work? That whenever a protection system or power system study we do, there are three pillars of any study. One, who know the system with the expert, that is consultant, energy. Second, who knows the process, that is our customer. We know our system, acquainted with the process, how my changeover or power is flowing there, that I know. And third one, it's product knowledge, which actually ABB, Siemens or other relay manufacturer is knowing about the project. So any protection or coordination study has to be integrate all these three pillars, otherwise that study is incomplete. So that has to be done. And third, fifth point, I will tell about embracing the new technology. And for that, I will go 10 out of 10 marks to the MEPL, no doubt about that. They always go forward for the new technology. And they present very gently, carefully, and with sincere encouragement, they give these recommendations or supports to the time. I'm most of the time I'm receiving the mail take that is tackling electrical concerns of today. So this really good mailer periodical or services you have been started, and I regular vivid reader of this text and looking forward for such things. So, and the way you explain this thing that Sanjeev sir given us that earthing system trainings. He has conducted, I think, I don't know, more than 10, 15 training. The way he presented this in lucid language, in illustrative way, that's a very great thing. See, point is that if you can't explain it simply, you don't understand it well enough. So the way he presented in simple way, it looks like the simple, but it's not simple. Putting a simple way, it's really actually hard way. It's a really tough way. But that ability, that attributes he have, and he knows what, or MEPL in that case knows what is the customer requires. So with all these things, actually, I congratulate IMEPL and we wish him very best for coming years, and he will be always our associate partners for enhancing our electric reliability system at our RIL, not in manufacturing, but all other our subsidiary. Thank you, Vijay. I'm honored you call me for this input. Thank you very much.
Thank you, sir, for your candid feedback. And actually, as rightly said, we at Manav are a learning organization. Actually, we have learned after failing 1,000 times, 2,000 times. So it is always a learning experience for any project. And you, our customer, the esteemed customers, have given us such good feedback that what Manav today is today. And we want to excel in the coming years and grow with you. Thank you, Ranjit ji, for your time.
Thank you, sir. Thank you.
So we also have heard during the discourse and the panel discussion, Mr. Anil Yadav, who is part of this august audience. So, but I would like to invite him once again. He is the head of rail systems of DB Engineering and Consulting. I would request him to express his views on today's deliberation and the experience he has had with Manav Energy. Anil Yadav ji, could you kindly unmute yourself and put on your camera?
So yes, thank you so much, and wishing Manav on their 10th anniversary, and again wish many more such anniversaries in the future. On the lighter note, I heard Savita ji saying that Manav was started from the garage, and I think she's already in the August group of companies like Apple and HP who started similar journeys, and now they are the leading solution providers of the world. And yeah, with solution provider again, I think what I recollect is my first meeting with Sanjeev, and that's where our journey started with Manav. And that is one of the things which again in today when we started the celebration, Savita ji mentioned, is that all of their partners do not consider them as another vendor, but a solution provider. And that is exactly, I could recall that the discussion that started. And today I can proudly say that yes, Manav has been a solution provider to DB, to myself. And the way we have started to depend upon Manav is not only for the work, but also for the transparency in doing the business, is that literally we don't even think about going to another solution provider. We don't even discuss the commercial issues with them. Once it is discussed, okay, can you do this job? And literally, I think there we finalize things. So if the Manav has the capability, we don't even think twice technically as well as commercially. We have been doing various projects. For the audience here, I would like to say that because DB is involved not only in India, but also globally, we have done various provided solutions to our final client, partnering with Manav. So if I can recall some of the examples, last year we did one work which was with Queensland, Australia. I believe that a normal time for that kind of work would be like 2 or 3 months. We asked Manav that can you do it within 1 month, and in that 1 month also probably I think 1 week had already passed by. And to my surprise, to the client's surprise, and to tell all of you here that we did that within that 1 month. And if I can recall from my memory, in my 30 years of professional journey, I don't know whether I've submitted a first report and that has been accepted as the final report. So this is the kind of, the proficiency that Manav has. And there are many more examples. Recently, we are now again doing some work for Doha Metro. Also, we are doing some work internally, whether it's with DFC, wherever DP is involved. So to quote examples, I think there are many examples to quote about, but yes, I think I could send the messages that yes, Manav is a trusted partner for us, and wish you again many more successes in the future. Apart from that, again on the lighter note, I don't know how many of you know that I think Munish is not so well, as well as I think his family is also not so well. I think the IIMs or the business school should do some study on the kind of dedication that Manav has with his team, that even with so much he is able to spare his time and be on this day with us. As far as the panelist, yes, it was a great learning for me today, and rightly mentioned as the hidden truth. There's no doubt about it. EMCMI or EMP, these kind of things, especially, I think the awareness is growing in India. But yes, maybe 10 years back or so, I don't even think that as electrical engineers, we were even thinking about such things, at least in this part of the globe. It's really nice for Manav to start building up on that. And as the electrical network grows, which certainly is growing day by day, these are the kind of things we need to know. And certainly to know that it's not any surprise, as one of the panelists mentioned, but yes, these are something which has a physical and logical reasoning behind it. As I said again, thank you to all the panelists and thank you to Manav. At the same time, wish you all the best. That's all from my side today.
Thank you, sir. Thank you, sir. Your words are actually really very encouraging and motivating for the entire team. Thanks a lot for sparing time for us, sir. And we are also honored to have you here. Thank you, sir.
Thank you so much.
Although there is a long list of completed projects with satisfied customers all over the world, our message to the industry is that you can depend on Manav Energy for all your electrical and C&I safety and reliability needs. Thank you one and all. Thank you from my desk.
I would like to introduce you all to the very man who has installed an LPS, a lightning protection system, on top of the world's tallest man-made structure, the Burj Khalifa. He is our business unit head for EMEA. I would like to welcome Mr. Pankaj Dikshit. Over to you, sir.
Hi, good afternoon, everyone. Thank you, Manoj. Indeed, it was a challenging project that needed a special attention and specific enterprise, to install lightning protection system at such a height of 831 meters. We have an experienced team that allows to weigh and suitably resolve the challenges to ensure the project deliverables. I consider privileged to be a part of that landmark occasion. We are all glad the 10th anniversary celebration went on well. Firstly, I sincerely thank the panelists and all our guests for being with us today and making the event memorable. Secondly, my heartfelt appreciation to volunteers and organizers for making this event a grand success. As a key takeaway of today's discussion, providing safety against electrical and electromagnetics hazard requires a structured process involving design, validation, and simulation of the proposed solution, followed by supply, installation, and commissioning. Our team of subject matter experts can provide solution remotely and at sites worldwide. With this, I would like to share my personal experience. Anilji and other panelists also has mentioned that EMI and EMP, they have the effects on the humans as well. I'll share my personal experience. My mother used to have a pacemaker in 1995. And whenever she used to pass by a fridge and there is a change of compressor load and all those things, she used to feel a pressure on the heart. So yes, that is truth. So having said this thing, at Manav Energy, we stand committed to delivering a reliable tomorrow. Thank you very much. Thanks a lot.
Thank you, Pankaj sir, for your kind words. Well, I have an announcement. The consulting calendar. What is it? What will it help you with? Well, we do have the answers for that. I'd like to say that you can use this consulting calendar to ensure that you take the right step towards protecting your lives, livestock, and assets. For more information regarding the consulting calendar, you can always visit manavenergy.com, and we are right now sharing the link in our broadcasting channel, so you can go through that. For more information, you can always connect back with us. And I once again like to thank all of you for being a part of Manav Energy's 10th anniversary celebration and making it memorable. Thank you all. Thank you. Goodbye.